Hello, and welcome to Distance Learning with Mr. Ross. Today we will be talking about reflection and refraction. Okay, so we've already discussed reflection, and we're just going to do a quick review. So if you recall, when a ray comes in to a smooth surface, we call that the incident ray. Okay. We draw the normal line to the surface, always. And we were shown that, and we demonstrated, that the light always, or the ray, always reflects off where the angle of incidence, we'll call that theta 1, is equal to the angle of reflection, which is theta 2. So theta 1 is equal to the angle of incidence, and theta 2 is equal to the angle of reflection. We also discussed when does theta 1 equal theta 2? Question mark. And the answer is always. As long as a ray reflects, this law is always followed. Okay, so here's an example for practice. Okay, if you'd like to pause the video now and do the problem yourself, that's fine, we could check. Okay, here's M1, here is M2. This angle right here is 125 degrees. A ray comes in with an angle of incidence of 40. Actually, it is not the angle of incidence. What is the angle of incidence? That's right, it is 50. Okay, so the ray comes in and is going to reflect at what angle? That's right, 50 degrees. Okay, so it bounces off of M1, mirror M1, and it's going to hit M2. Okay, we redraw the normal line, and we have to figure out the new angle of incidence. Well, if that's 50 degrees, we know that this is 40. Okay, if that's 125, that's 165. Well, we have a triangle here, so 165, 180 minus 165 is 15 degrees, which is here, which means that the new angle of incidence is 75 degrees. Well, the question said, what is the angle of reflection? Well, if the angle of incidence is 75 degrees, the angle of reflection must also be 75 degrees. And that is your answer. Okay? All right, so now let's discuss what is the difference between regular reflection and diffuse reflection. Okay. Well, regular reflection is basically what we've seen so far. A ray comes in, okay, we draw the normal line, it reflects in that V-shaped pattern, okay, where the angle of incidence equals the angle of reflection. Well, what would happen if parallel rays come in? If parallel rays come into a smooth surface, smooth, regular reflection, well then we redraw a new normal line, and all of the rays that come in parallel are going to reflect parallel. And that is regular reflection. Very simple. Okay? Well, what is diffuse reflection? Okay, well, diffuse reflection happens when the surface is irregular. So diffuse reflection is when the surface is irregular. Okay, well, let's draw an irregularly shaped surface. It has bumps, it has all these grooves, okay, just like that. Well, what happens when a parallel ray comes in? Well, when a parallel ray comes in, does it follow the law of reflection? And the answer is yes, always, always. But remember, the normal line is always drawn perpendicular to the surface. So at this point right here, if I were to draw the normal line, let's say the normal line looks like this. Well, that ray will go off like that. Okay? Let's say I drew the normal line at this new point right here. Well, let's say the normal to that surface is right here. Well, it's going to go off according to the law of reflection like that. Okay? So, for example, let's say, let's say the third ray comes in. Third ray comes in. Let's say the normal to the surface is like this. Well, it's going to go off like that. So basically what's going to happen is it comes in parallel, but all of the rays bounce off in all these different directions according to where the normal line is. Okay? So like, for example, just to show you in more detail, let's say here is the surface. Okay? At this point right here, the normal line would be here. At this point right here, the normal line would be here. Over here, the normal line would be over here. And therefore, basically what's going to happen is if you were to shine, let's say, a laser on an irregular surface, all the energy is going to bounce off in all these different directions. So you're not going to see that nice V shape that we saw in class. Okay? All right, that's diffuse reflection. All right. Very quickly, let's do a little review of refraction. Okay, so refraction, once again, is the bending of a wave as it travels from one medium to a different medium at an angle. And we saw this on the blackboard. Okay, I showed you as light ray came in. We saw in the lucite block, we saw the light ray came in and it hit the surface and it bent in this direction. Okay, and we'll explain later on why it's in that direction. Okay, so the incident ray came in, incident ray, and it was refracted. This would be called the refracted ray right here. That's the refracted ray. Okay, we call this theta 1. Theta 1, again, is the angle of incidence. Okay, this angle down here, theta 2, that angle would be the angle of refraction. Okay, now at the boundary something else happens. What happens at this boundary here? That's right, we have some partially reflected, this is a partially reflected ray. Okay, and theta 1 prime, we know that theta 1 is going to equal theta 1 prime. Those are going to be equal. Okay, all right, so that's just a little quick review of refraction. Okay, now we saw a demonstration before you guys left of a ray. I pointed a laser at the center of a beaker, and we saw that the light came in straight line path and it hit the center of the beaker. Okay, we then filled up the beaker with water. Okay, so that we filled up the beaker with water. This is all water over here, air, water. Okay, and we saw that the ray no longer hit the center of the beaker. We saw that the ray actually bent or refracted. Okay, so here's our new normal line, and we saw that the ray actually bent like that. Okay, so it came in. Actually, we'll keep that. Came in, and instead of going straight, it came in and it bent downwards. Okay, towards the normal line. Okay. All right, we're going to talk a little bit more about this in some future lessons. But before we wrap up for today, I want you to to try something on your own. Okay, it's called the reappearing coin. Okay, so here's how you do it. Okay, you take a beaker. Okay, I don't know if you could see me in the camera. Let me just back down a little bit. Here we go. All right, so basically what you do is you take some kind of beaker. Okay, have the beaker so that you can't see through it. So don't use glass. Try to take either a wooden bowl or something that you can't see through. Okay, what you're going to do is you're going to take a coin. You could take a penny. And what you're going to do is you're going to tape it to the center of the beaker. Okay? You tape it to the center of the beaker. You then look over and you find the penny. So in other words, you should be able to see the penny right now. And then what you do is you move the beaker further away so that it's just out of sight. Okay? Now, what happens is you then ask either your parent or your friend, okay? So what happens is at this point, when you look over, you find the penny, and then you move back just so that the penny is out of reach, okay? Then you have your friend or parent fill up the beaker with water, okay? And see what happens. All right. Talk to you tomorrow. Bye, everyone.